Hey all, Nate Allen here again, coming at you with some trig equations, part one, two-part series here. I'll have the follow-up after this. So this one, we're going to be dealing with equations now and actually trying to solve equations like we have in all of our algebra, but now with trig functions as well. So we're going to have to utilize some of the inverse stuff that we just went over, as well as some of our algebraic backgrounds. So hopefully you guys are ready for that. Here we go. First thing I'm going to start you off with is just to try to make sure that everybody's up to par with their algebra skills and how to solve an equation. Now we're going to add in the extra element of it having trig functions in it as well. So basically trying to figure out what kind of equation it is. Is it of that linear form or a quadratic form so that we know how to solve it? Whether or not there's only one trig function, that's definitely helpful because just like we've always had any type of algebraic equation, it was very easy when there was only one variable to solve for. So same thing with trig functions. If there's only one, much easier to solve for. If more than one, then just like when there was more than one variable, like an x and an x squared, we always wanted to get one of the sides set equal to 0. And then we tried to factor, which is our quickest, easiest method, if it was a quadratic. And from there, we could then set each of those factors equal to 0 and get our possible solutions. So not a lot different here other than how we finish is going to look a little bit unfamiliar. Um, Hopefully it won't be too unfamiliar because we are dealing with trig and we have been for quite some time, but those are the types of things that we're going to be getting into, and also having to utilize some of those identities that we've talked about as well. So every once in a while you may have to use the quadratic formula, but most of the things that we'll be dealing with will be factorable. So get it set equal to 0 and then try to use that zero factor property in order to find the factors and then set those factors equal to 0 to get your solutions. Our goal is still to get the variable by itself. In this case, first we got to get the trig function by itself before we can solve for x or theta or whatever they ask us to. So that's pretty much the notes as far as not a whole lot new. Just going to go over a few different types of looks here and see what you guys think on what this kind of looks like and hopefully the familiarity of the process. So first thing we're given is an equation with tangent theta in it. And so of course, just like always, we're going to try to get the variable by itself. In this case, we're going to treat the whole tangent theta as our x, as our variable to start. And so our first step is going to be obviously to undo everything that's been done to it, starting the furthest away. Reverse order of operations, if you will. So if I was to plug in something for theta, I would evaluate tangent, then multiply it by 3, then subtract the root 3. So I'm going to go in reverse order, also known as the inverse, by adding the square root of 3 to both sides. So then that becomes a 0, and I'm simply left with 3 times tangent theta equals 0 plus root 3, which is the square root of 3. Next, I'll go ahead and try to undo the multiplication by dividing both sides by 3. And now that becomes a 1 times tangent theta, and it's equal to the square root of 3 over 3. And if you remember, this is stuff that we've talked about many times before. Basically, what we're trying to do now is figure out what angle, theta, for tangent that gives us root 3 over 3. Now, the problem is, unlike the previous section where it was the inverse, we only wanted one answer. This time they're asking us to give everything from 0 all the way to 360. Notice including 0 with the bracket, excluding 360, because they are the same point. And since we know it's positive, we know there are two different quadrants where tangent is equal to a positive. And in this case, we are definitely not looking at quadrant, use a different color here, 2 or 4. So we're looking for a reference angle in quadrants 1 and 3 for tangent that gives me root 3 over 3. And in this case, hopefully we all know that. This is why, again, I worked so hard to try to get you guys to memorize these. We should know that the angle, we call it the reference angle, for tangent that gives us root 3 over 3 would be 30 degrees. But remember, that is just our reference angle. Our answers are therefore going to be in quadrant 1 and quadrant 3, which means we're going to take 180 degrees and add 30 to it. So our answers for theta in quadrant 1 is our reference angle 30, and in quadrant 3 it would be 180 plus 30 for a total of 210 degrees. Now, if you notice, there's a part B to this that asks for all the solutions. And a lot of you might be thinking, well, that is all the solutions. But remember, that's all the solutions within this one period or cycle, rotation, revolution, whatever they want to call it. To get every single solution, hopefully you guys remember what we could do to each of these two possible answers. How can we always get to the same place, but with a different rotation? And hopefully you said it. Add 360 or subtract 360 any number of times. So in this case, we're going to have to do that to both, where n is any integer, positive, negative, whole number. And so in order to give them all the solutions, we will simply say our answers are 30 plus 360 n times, and comma 210 plus 360 n times, where n is any integer, positive, negative, whole number. And that's it. I mean, this is pretty straightforward stuff.